Okay, so on this problem, we're trying to solve for x. I'll rewrite it down here. 13 e to the x minus 19 equals 8. Okay, and what should we do? What should be in our mind? Well, basically, x is up there in the power zone, isn't it? And so what we're going to need to do eventually is do the natural log of both sides. But first, step one is get the e to the x alone. So this piece right here, the base with the power on it, we have to get that alone, and then we'll L in both sides because logs are the opposites of powers. All right, so let's first get it alone. So, so my first step here, I'm going to add 19 to both sides. Boom, boom. Bring this guy down. 13 e to the x is 27, like that. All right, keep going. We still got to get this e to the x is still right here saying I want to be alone. So, all right, next step, divide by that 13, right? All right, and then we've got e to the x. Now, as far as this 27 over 13, I would just leave it that way for now. It's easier. If you hit the buttons on your calculator, you get some long decimal, bunch of numbers. You don't want to write all that down. Plus, you're going to have to round at some point, so it's less accurate. Just use this. This is easier, quicker, and it's more accurate. Just leave it. We're about to do the calculator thing. Just leave it. All right, so now, that's all step one. Get the e to the x thing alone. We did that. Now, step two is ln both sides. And how do we know? I want to help you on the exam and stuff, you remember, because there's no ln here. How you can remember to do ln? Well, because it's the opposite of e to the x, right? When x is in power, up there in the power zone, then the opposite of x in power is a log. That's why logs were created, for this very reason, to solve these kinds of questions. They're the inverses of exponentials. All right, so ln on both sides. ln on both sides, like that. E to the x, or let me keep the wall going here. Okay, and oops, I kind of missed it. And equals. Okay, so I did ln on both sides. Now, what does that accomplish? What does that do? Well, that allows this x power to drop down to the front. Remember that? Remember that those properties of logs, which says the power on a log or a natural log, either one, can drop down to the front. So that's why it works. So then we get x ln e equals ln 27/13. Now, here's the important question. What's ln e? What's up with that? What's ln e? Well, it turns out ln e is just 1. You can check it on your calculator if you want, but we're going to be doing it all the time. It's just 1 because they're opposites of each other. So don't even bother with it. Just say, all right, that's 1, that's gone. So this is just x times 1. So this is just x. As far as the other side, hit the buttons on your calculator. So I'm going to do that right now as we speak. ln of 27/13. And I'm getting 0.73088. How far do they want me to go? Oh, 4 decimal places. Notice. Okay. All right, so I went to 5. So remember how we do 4 decimal places? So you're going to stop right here at the 4th decimal place, aren't you? That's where we're going to stop. So the one to the right being 5 or more means rounded up. So it would be 0.7309. And that's our answer. So what do we do then when we have x in the power zone? Step 1, get that base to the power thing alone. Step 2, ln both sides. And then the power comes down, and then we can finish solving. So there we go.